Welcome to this video on thread synchronization in Java. In multi-threaded applications, synchronization is essential to prevent conflicts when multiple threads access shared resources. In this video, we will discuss race conditions, synchronization mechanisms, and how to use intrinsic locks and reentrant lock to ensure thread safety. A race condition occurs when two or more threads access shared data concurrently without proper synchronization. This can lead to unpredictable results and inconsistent states in your application. For example, if two threads try to increment the same counter variable simultaneously, the final result may not reflect both increments due to how the threads interleave their execution. Synchronization is the solution to race conditions. It ensures that only one thread can access a critical section of code at a time. This prevents multiple threads from modifying shared resources simultaneously, ensuring thread safety. In Java, you can use the synchronized keyword to synchronize methods or blocks of code. This ensures that only one thread can execute a critical section at any given moment. There are two ways to use synchronization. Synchronized method. The entire method is synchronized, so the thread acquires the lock before executing the method. Synchronized block. Only a specific block of code is synchronized, providing more control over what needs to be thread-safe by restricting the synchronized section to just the critical parts of the code. Every Java object has an intrinsic lock, also known as a monitor. When a thread enters a synchronized method or block, it acquires this intrinsic lock. Other threads trying to enter the synchronized section must wait until the lock is released. This mechanism ensures that only one thread can access the synchronized section at a time, effectively preventing race conditions. Java's synchronization mechanism is reentrant, meaning a thread can acquire a lock it already holds. The reentrant lock class provides a more flexible locking mechanism compared to the synchronized keyword. By using reentrant lock, you can have more control over the locking process, such as attempting to acquire the lock without blocking or responding to interruptions while waiting for the lock. To summarize, a race condition occurs when multiple threads access shared data concurrently, leading to unpredictable results. Synchronization ensures that only one thread can access a critical section at a time, using the synchronized keyword. Every Java object has an intrinsic lock that threads must acquire to enter a synchronized block or method. Reentrant lock provides a more flexible way to manage locks, offering additional capabilities beyond the synchronized keyword. Understanding thread synchronization is crucial for building thread-safe Java applications. By effectively managing access to shared resources, you can prevent race conditions and ensure the correctness of your multi-threaded programs.